Everybody, we're going to start the lesson right now for lesson 3, topic 1 from our new module 4. We have, this will be due on Tuesday, April 14th. We're going to start with the warm-up. Represent each fraction or percent as a fraction in its lowest terms. Well, I know that this is the tenths place, so I can start right away with that equals 3/10. Now, to make it lowest terms, I have to ask myself, can I simplify it? I cannot simplify it any further than that, so I'm going to leave it at 3/10. 2.8 would really be just 28/10. So I'm just going to rewrite that as 28/10. Now, can I simplify it? I can. I can simplify it by dividing both the denominator and the numerator by 2, and I get 14/5. Now, if I wanted to convert that to a mixed number, I could say, well, there are 2 5s and 14. That leaves me 10. So I have 2 wholes, and then I have 4/5 left over. 3/4%. So it's asking me to reduce that into its simplest terms. And it wants it in a fraction. So 3/4% is actually going to be less than 1%, which is going to be 75 10,000ths. And there's no way to simplify. Well, I suppose I could pull a 5 out, right? Divide each one by 5. That's going to give me 75 divided by 5 is really just like 15. So I probably could have taken another 5 out or 25 out, and that would give me 400 over 3/400ths. I actually added an extra step here. I could have taken 25 out. 25 times 400 is 10,000. 25 times 3 is 75. And then 212% is like 2.12, which would equal 212 over 100. So what can I take out of here? I can definitely take 2 out of here. Be 106/50ths. I could probably take 4 out of here. 212 divided by 4 would be the 12 is divided by 4. That gives me 3, 253/25. There you go. And that's your warm-up. The main reason here is we want you to understand that a decimal can be expressed as a fraction can be expressed as a decimal, a percent can be expressed as a decimal, and then as a fraction. This is really important to understand the definition of rational numbers. So what's in a name? We're going to come up with a numbering system, the way to categorize and organize and classify different types of numbers. That's our essential question. So we'll take a second to write it down. How do we organize and classify different types of numbers? How do we organize and classify different types of numbers? Now, I'm going to give you 4 definitions, and then we're going to go over them together. Okay. A natural number, we have 4 different types of classifications of numbers. A natural number is just any whole number. It's greater than 0. No negatives, no 0. Okay, so these are just our counting numbers. Okay, just our counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so forth. Not including 0, not including negatives. Okay, our whole numbers are going to be that same group of natural numbers plus 0. So it's our counting numbers and 0. So the only difference between whole numbers and natural numbers are that whole numbers include 0, natural numbers do not. Now we're going to talk about integers. Integers are any number that does not include decimals or fractions, and it includes negative numbers. Okay, so you can't have negative, no decimals or fractions. So these are just counting numbers and opposites, right? And that would include 0, counting numbers, 0, and opposites. So you have 3 and negative 3. They're both integers, even though 3 is only 3 is a natural number and a whole number. It's also an integer. Negative 3 is an integer, but it's not a natural number or a whole number because it's negative. And then finally, rational number. We've gone over this definition a lot. Any number that can be written as a over b, where b does not equal 0. So this includes integers and fractions and decimals. Positive or negative. Positive or negative whole numbers, positive or negative fractions, positive or negative decimals. So go ahead and take a minute, pause that, make sure you have that written down. That will help out quite a bit. Okay, we're going to move on. Now we're going to go a little bit out of order here, a little bit out of sequence. We're going to go to the end of section 3.2. So we'll do this part next. 3.2 is classifying numbers. We're going to go ahead and go to the last page of, the next page of this PDF that has problem 2, complete the table with the missing examples and descriptions. And we're going to do that together, okay? It's a great way to go through this. So looking at our definitions, okay, and filling out this chart. It says natural numbers are our counting numbers, right? 1, 2, 3, 4, 5, 6, and going on, there are counting numbers. Whole numbers are our natural numbers and 0. So I'm going to go ahead and write a 0, 1, 2, 3, ... So we've got our natural numbers plus 0, okay? Integers, they've filled this in for us. -3, -2, -1, 0, 1, 2, 3. So this is whole numbers and their opposites. All right, whole numbers and their opposites. And then finally, rational numbers. Well, we have a lot of different things that we should put in here, right? We should put in -1/2, -0.25, (0.25). I'm sorry. How about go -1, -1/2, -0.25, 0.25, +1/2, +1, right? So rational numbers are integers, fractions, and decimals, including negatives. Okay. So we can have integers, which are basically whole numbers with their opposites. We can have fractions, decimals, and rational numbers, and we can also have negative numbers in rational numbers. So we have negative fractions, negative decimals. That's why the warm-up was the warm-up, because it wanted you to connect again what a rational number is, and that it can be expressed as a over b. So -1 could be expressed as -1/1. -1/2 is already a over b. And then -0.25 could be -1/4. It expressed as a over b. So those are all our different types of rational numbers. All right, now we're going to do the work. So this is our graphic. We have our definitions that we've worked on. Okay. And basically what it's saying here is that we have this bullseye, okay? And in this bullseye are the natural numbers. That's the most restrictive definition, the natural numbers. It can only be the counting numbers. The positive counting numbers doesn't include 0. Okay. Then we go to this next ring, and it's the whole numbers. Whole numbers are all the natural numbers plus 0. Okay. All natural numbers are whole numbers, but not all whole numbers are natural numbers because natural numbers don't include 0. Now we're going to go to this next ring. Okay. Integers are whole numbers and their opposites. So all whole numbers are integers, but not all integers are whole numbers because the integers include the negative opposites. Whole numbers are just the positive numbers. Now, we go to this next ring, integers, and outside of integers is rational numbers. All integers are rational numbers. Positive and negative whole numbers and opposites are what integers are. They're all rational, but not all rational numbers are integers because rational numbers include decimals and fractions, both positive and negative. All natural are whole. All whole are integers. All integers are rational. Okay. But not every rational is an integer, not every integer is a whole, and not every whole is a natural number. That's why we built it like this bullseye. All of the natural numbers are inside the whole numbers. All of the whole numbers are inside the integer numbers. All of the rational or integers are inside the rational numbers. But there are whole numbers that aren't natural. There are integer numbers that aren't whole, and there are rational numbers that aren't integers. Okay. So we're going to fill these first two out together. All right. And then you'll do the rest on your own. First off, number 3, is it a natural number? Yes, because it's a counting number. Is it a whole number? Bring this down a little bit. And if it's a natural number, I know that it's a whole number. And if it's a whole number, I know that it's an integer. And if it's an integer, I know that it's a rational number. Okay. All right. 3.22, I have a decimal here, so it can't be a natural number. It can't be a whole number because it has a decimal. It can't be an integer. This is only a rational number. Now your job will be to go ahead and finish these and watch the next video to check your answers.